update to accompany my blog posting on my Rube Goldberg machine project. This is the culminating assessment of my 8th grade physics unit, in which students take all of the things that they've learned from throughout the unit and build a machine that allows them to demonstrate their understanding of those concepts. I've posted a full lesson plan for this project with lots of different materials that I use to support my students throughout the project. I think that it's one of my favorite projects because of how it brings together so many different things. It's an incredible STEM project that teaches students not just physics concepts, but problem solving. They're using technology to analyze their machines. They're also using math to do calculations of changes in velocity, potential versus kinetic energy of a marble in their machine. There are a couple things that I've included that I want to talk a little bit about. The first thing that you'll find in my posting is a rubric. I use this rubric, I pass it out to students at the beginning of the assignment because I want them to know what they need to do to be successful. It helps them structure their work. It also helps them plan where they are, where they need to be, and where they're headed. I begin the unit with another tool, a brainstorming guide, where I have students brainstorm possible steps, things that they might include with the machine, ways that those steps might connect to one another. In order to get lots of ideas generated within a group, I have students do their brainstorming individually and then come together with the group to share their ideas and figure out how they can link them together. It's pretty rare that a machine actually looks like what the students draw at the beginning, but it gives another opportunity for students to reflect on how the machine changed from their original plan and also be able to talk about why that happened. Something new that I created when I did this project this year was a worksheet that helps guide students through the actual construction. They list the tasks that their machine is trying to complete, in this case lifting a tissue from a box, and you see that they have listed all of their individual steps. They're required to have 8, this group had 10, and I had them do it with post-it notes, and that allowed them to be able to move the steps back and forth. If they pulled the step, they were able to just remove the post-it note rather than having to rewrite everything. If they reordered the steps, they were also, again, able to move those notes around. At the very bottom is a list of the simple machines. Students are required to have 5 simple machines as part of their Rube Goldberg project, and this helped them self-assess where they were. What do I need to add? What's missing? What are the next things that we need to work on? How can we figure out who's working on what next? I encourage you to look through the lesson plans and project materials that I posted, and I'd love to hear how you use the Rube Goldberg project in your classroom. What are the ways that you adapted it to make it your own? What are the ways that you engage your students? And what are some of the challenges that came up, and how did you work through them? Please feel free to email me at michael@thescienceguru.com. I'll include your ideas in an upcoming post, or post your own video as a response to this about how you used the Rube Goldberg project in your own classroom. Again, this is Mike from thescienceguru.com. Have a great day.